1.8 reviews inequalities. Inequality symbols, there are 4 of them: less than, greater than, less than or equal, greater than or equal. And the way to remember, you're always pointing toward the smaller value. Linear inequalities. Linear is when the power and the variables equal exactly 1 and no variable appears in the denominator. We operate on the inequality symbols like we do an equal, except when you divide or multiply by a negative, you must switch the symbol. Keep in mind those 2 symbols, less than or equal, greater than or equal. Graphically, you will fill in the dot. Interval notation, you would write a bracket. That means it's included. Less than, greater than, strictly with no equal. If you draw in the solution, you draw an open circle, even though now they're including the brackets or parentheses on the graph. I'm going to stick with the circles. Parentheses for not included, and that means it's not included or excluded. Anytime you're reading interval notation, you read the graphical solution from left to right. Remember, we never ever include positive or negative infinity as a solution, so we never put a bracket on infinities. So we're going to start off with a simple, straightforward example. Example 1. Solve the inequalities. We treat inequality like an equal. Subtract 3 from both sides. Divide by 2 both sides. That's the algebraic solution. Sketch a graph. You draw yourself a graph. All what you have to do, put the point in question. That is included. So I'm going to put a closed circle. X is less than. X is less than. A number to the left is always smaller than the number to the left. So less than, you always shade to the left. Greater than, you shade to the right. That's a graphical solution. Interval notation, you read the graph left to right. How far to the left does this go? This runs to negative infinity, comma, all the way to 1. 1 is included. Even though this runs to negative infinity, we never include infinities. This is the algebraic solution. This is the graphical solution. And this is the interval notation solution. So you must know all 3. Next problem, same deal. I see a fraction, I think of an LCD, and I never ever have to deal with fractions. Make sure they all have it. And once all the denominators have it, you ignore all the denominators. You just read the top. That reads x plus 2 times 4 is 8, less than or equal to 2x minus 6. And there it is. It's wiser to move the smaller to the larger, so subtract x from both sides. Add 6 to both sides. And you always read an inequality from where the variable is. If I look at the variable, this reads x is greater than or equal 14. 14 is the only point that I labeled. That's the only solution I have. No need to label 0, 1, 2. Less than or equal included. X is greater than. Greater than, you would shade to the right. So this is the algebraic. This is the graphical. And now the interval notation left to right. If I look at this from left to right, the first point that I come across is 14. And this runs all the way to infinity. Included. We never ever include infinities. So the 3 types of solutions I'm going to ask for on your test. Solve, that's algebraic. Express your solution using interval notation, and graph the solution or the solution set. Oh, solution set. I did say solution set. Same deal with the next problem. LCD is a 4. Multiply by 2 top and bottom. Multiply by 4 top and bottom. Read the top. 22 minus 3x is less than 20. Subtract 20 from both sides. Subtract 22 from both sides. 20 minus 22 is a negative 2. And what happens when I divide by a negative? I must switch that symbol. That's the algebraic solution, the graphical solution, Again, no need to worry about where 2/3 is. You're supposed to know where that is, but only need to label the point, not included. X is greater than, you shade to the right. Well, interval notation, left to right, the first point I encounter is 2/3, but it's not included. And this one's all the way to infinity. That's the interval notation solution. Next set of problems. This is negative 2x minus 1 over 10 is greater than 3 over 10 plus 5 over 10. No need to deduce anything. LCD for the problem is at 10. Very easy to play with. So since they all have it, all what I have to do is say that's negative 20x minus 1 is greater than 3 plus 5x. Add 20x to both sides. Remember, you could add or subtract all you want. When you multiply or divide by a negative, you need to switch the symbol. So that will be 5 plus 20 is 25x. Subtract 3 from both sides. Divide by 25. If I wanted to sketch a graph, negative 4 over 25, not included. This reads x is less than. So the interval notation these are the three solutions. Same deal with the next problem. Over 1, LCD is 3. Now that they all have it, read the tops only. This reads x minus 3 is less than x. Subtract x from both sides. Anytime in math you're solving an equation or an inequality and the variables cancel out, that means either there's no solution or there's an infinite amount of solutions. Anytime the variables cancel out altogether. In this case, the variables cancel out, whether it's an equation or an inequality. Well, negative 3 is less than 0. Is that true? If this is 0 and this is negative 3, is negative 3 less than 0? Well, yeah. Numbers to the left are always less than numbers to the right. So this is true. If you want to sketch the graphical solution, and it's true, you're saying all real numbers. Any number will work. So, shading the graphical solution will be the whole number line, and the interval notation will be negative infinity to infinity. There it is. So, f, the same deal, 2x plus 4 is greater than 2x plus 6. Subtract x from both sides. Subtract 2x, and the numbers cancel out. If the numbers cancel out, that right there means, so algebraically, I forgot to mention, algebraically you would say all real numbers, any number will work. Here, 4 is greater than 6, that's false. If that's false, you would say, either you say no solution, or you give this symbol. This symbol stands for the empty set, null. That means there's nothing there. That's not 0. If you want to draw the solution, well, you can. You put a line and you mark nothing on it. And interval notation, you would just draw an empty set. That's how you show there's no solution. That's how you show there's an infinite amount of solutions, and that's the traditional one solution case. Couple more to go. I wanted to touch on everything that you come across on the homework. There are double inequalities, and what the double inequalities indicate, this quantity is between 6 and 11. How do you solve double inequalities? There are no triples, just double. You treat it just like if I had 2x minus 3 is less than 11, or 6 is less than or equal to 2x minus 3. Wouldn't you add 3? That's the first order of business. Whatever you do to one side, you do to each side. That's about it. Do keep in mind, if you divide by a negative, you have to switch both of those. and divide by 2. Since I didn't divide by a negative, that rule doesn't apply. And it's very easy to put this on a number line. Anytime you see an x between two inequalities, the right is not included, the left is, and this reads x's between. Fairly simple. Let's see if that's gonna work. Not bad, it did. And that would be 9/2 to 7. Again, double inequalities with x, provided they're pointing in the same direction, indicate that x is between those. And what if we come across a fraction? So what? LCD is 15 multiplied by 3 top and bottom, 5, ignore the denominators, negative 3 is less than 5, minus 3x less than or equal to 5. Subtract 5 from each side. And what happens when I divide by a negative? That's the only exception to the rule. I will switch those. Oh, when I subtracted 5 from both sides, that should have been a 0. So that's the algebraic solution. How would you graph that? You would put the smaller number to the left, larger number to the right. The larger number is not included, the small number is, and you shade x's between those. And there it is. And that's normally how it works. It's fairly simple. If you come across an absolute value, if the absolute value of x is less than a, so you remember, you need to isolate the absolute value first, then that means whatever's inside the absolute value is between negative a and positive a. Well, that means automatically take negative a, take positive a, not included, and shade it. Done deal. If you have an absolute value of x is greater than a, that means x is greater than a or x is less than negative a. That means you would draw negative a and positive a again. If it's a greater than, that would be the solution. So this is how I memorized it back in the days. If I see a less than, it's between, otherwise it's on the other side. So solve the absolute value inequality, express the solution using interval notation, and graph the solution set. Well, I see that the absolute value is on one side, everything else on the other side, and it's between. According to the rule up there, I take the 3x and I write a double inequality. To the right side, I put that, and to the left side, I put the opposite of that. Divide by 3. I didn't break the rule because 3 is positive. So x is between 4 and negative 4, and it's fairly simple to solve. That is, on a number line, I just put a line. I run the smaller on the left, the larger on the right, not included, there's x, and negative 4 to 4. Here, there's a small trick. I need to isolate the absolute value by itself. I would divide by 2 first. This is not a less than. So this is either x is greater than or equal to 2, or x is less than or equal to negative 2. Algebraic solution. Graphically, what that means, I would go to 2, negative 2 included, and not the between part. So interval notation, this runs from negative infinity all the way to negative 2, union with 2 to infinity. And if I look at this problem, I notice the absolute values on one side, everything else on the other side. There's a less than, so whatever is inside the absolute value and a double inequality. That number to the right and that number to the left before you do anything. Now, me personally, this you don't have to do because you're doing an extra step, but me personally, I'll find the LCD. 2. And this way, I don't have to deal with fractions. Read the top, negative 1 less than or equal to 2x minus 6. Now, you are adding an extra step to the problem, I understand that, but I'd rather deal with integers than decimals. Add 6 to each side. Negative 1 plus 6 is 5. 1 plus 6 is 7. Divide by 2. The graphical solution, 5 over 7, 7 over 2, both included. X is between those. And there it is. I was going to do the rest. Let me see if there is sufficient amount of problems.